11.4 Solving linear systems by multiplying first. Okay, first I'm going to review some vocabulary with you. The first word is linear equation. This is an equation that will graph as a straight line. You can see here that our x variable does not have an exponent, our y variable does not have an exponent, and you can either have a variable equal to a number, like in these two equations, or you could have variables equal to variables, but none of the variables have exponents. So this is what makes them linear. So the exponent here would be a 1, and here a 1 also, but there's nothing higher than a 1. Our second word would be system of linear equations, which is a collection of two or more equations with the same unknown values. So you can see in our first example that I have a set of two equations, a collection of two, and you can see that they have the same set of unknown values. They both have x's and y's that I don't know what their values are at this point. And you can see in example number 2, I have 3 equations, which the definition says I can have 2 or more. So since I have 3, I have more than 2. And they all have the same set of unknown values, which in this case it would be x, y's, and z's. For this class, you'll only be using 2 equations at a time. In this lesson, here are the steps for solving a system of equations by multiplying first. Number 1, decide which variable you want to eliminate. Number 2, multiply one or both of the equations by a constant so that adding or subtracting the equations will make sure that one of the variables will eliminate. Number 3, solve the system using the elimination method, which we learned in the previous lesson. Before we get started with working with some problems, we need to review how to find an LCM, which is called the least common multiple. The least common multiple of 3 and 4 is 12. But why? So you need to learn to do this very quickly. When you see two numbers, 3 and 4, you automatically know that the least common multiple is 12. Now, a multiple is just a multiple of numbers. So, for example, the number 3 has multiples of 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, just like your multiplication tables. For 4, your multiplication tables would be 4, 8, 12, 16, 20, 24, and so on. But the least common multiple would be the one that appears in both of the lists first, because it's the smallest. The numbers 3 and 4 have other multiples, like for example 24, but that is a bigger multiple. You want the smallest one possible, which the first number that appears the same would be 12. So 12 would be considered the lowest of the common multiples of 3 and 4. Let's try another set. You can find multiples of many numbers. So for example, in this example, you can see that our numbers would be 2, 3, 4, 6, and 8. So the fastest way to do this would be to take your largest number, which would be 8, and look up the multiples of 8. So you can see that the multiples of 8 are 8, 16, and 24. Now what I like doing is checking to see which one of these. I could keep going on my list, but most likely I'll get something in the first 3. You can check to see if 2 goes into 24, 3 goes into 24, 4 goes into 24, and it all has to go in evenly, and 6 goes into 24. Now, since all of the numbers can divide evenly into 24, 24 would be your least common multiple. You could also just list all your multiples and then find out which one's the first one that matches. So 24 seems to be the first one that matches on all of the lists. Here is one more example. We're going to try to find the least common multiple of the number 3 and 5. So if you list the multiples of 3, 3, 6, 9, 12, 15, And then you list the multiples of 5. You find 5, 10, 15. 15 is the first number on the list that matches. That is our least common multiple. Some people want to just multiply their numbers together, which is sometimes a good idea and other times it's not. So some people might say that, well, you could just multiply 3 times 4 and you get 12. Yes, but here you're not going to multiply 2 times 3 times 4 times 6 times 8 and get 24. So you have to understand what a least common multiple is in order to find a least common multiple. In this case, yes, of course, 3 times 5 gives you 15. For example, let's take a look at the numbers 8 and 12. If you multiply 8 times 12, you end up with the number 96. And that number actually is not your least common multiple. You can divide both numbers by 2. 2 goes into 8 4 times. And 2 goes into 12 6 times. And you find out you can divide both of those numbers by 2 once again. So 2 by 2. And 2 goes into 4 twice. And 2 goes into 6 3 times. Since 2 and 3 are prime now, I can't keep dividing by the same number. There is no number that goes into 2 and 3 evenly. Now that I've divided as much as I could, you're going to see that you have all of these numbers here. And if you multiply those numbers together, 2 times 2 is 4, times 2 is 8, and 8 times 3 is 24. And that means that your LCM is equal to 24, not 96. Because if you remember from earlier, if you multiply 8 times 12, it gives you 96. But that is not your LCM. Your LCM is 24. And you notice that 24 is a lot smaller than 96. You can see here that this was a problem that I did in class. And so what they were asking you to do was to solve both of the equations for y. We solved the first equation for y by dividing every number by 2, leaving us with y equals to 2x plus 4. And of course, we moved the negative 4 to the other side. That's why it's on this side and positive. For the second part of this problem, they wanted you to multiply by 3. So we take our equation and multiply everything by 3. So 3 times 2 is 6. 3 times 4 is 12. 3 times 8 is 24. We're going to take each one of these numbers and divide it by 6 because 6 goes into all of them evenly. And we end up with y equals 2x plus 4. Now, of course, we had moved the negative 12x to the other side. So that this is why the 12x is on this side, on the right side. And so we end up with y equals 2x plus 4. If you notice, the two equations are the same. They're trying to teach you here that even though you multiply an equation by 3, that it really is not going to change the problem if you multiply a number into the equation. I'm going to work on number 7 with you. If you notice here, in order for us to find an LCM, the first number that we find as a multiple of 5. 5 times 1 is 5, times 2 is 10, times 3 is 15. That's the first number that 3 goes into evenly. So I would need to turn both of these numbers into 15s. And of course, one would have to be negative for them to cancel. In this variable, the y's, you can already see that I have a negative and a positive. And my LCM, I'm going to have to find that. So I'm going to show you how to find that, but I am going to work with my y's in this case. Now, since 2 and 5 cannot be divided by the same number, I will multiply them together. So 2 times 5 gives me 10. I need to decide what I'm going to multiply both of my numbers by. So if you notice here, I am trying to multiply the negative 2 by a number. So 2 times some number will give me 10. And 5 times some number will give me 10 also. So the numbers that I'm supposed to fill in right here, 5, are the number 5 and the number 2. That will give me negative 10 and positive 10. And eventually those two will cancel out. So now I know what I need to multiply both of my equations by. The first equation is going to get multiplied by 5, and the second equation is going to get multiplied by 2. So our first equation is going to get multiplied by 5 on both sides. And our second equation is going to get multiplied by 2 on both sides. Now let's go do that. So our first equation is 5 times 5 is 25. And 5 times 2 is 10, so negative 10y. And 11 times 5 is 55. Our second equation is also going to change into, so it turns into 2 times 3 is 6x, 2 times 5 is 10y, and 2 times 19 is 38. Now we can actually add our equations together. So we're going to use the elimination method from the last lesson where we can add them together. So I'm going to add these two equations together, and as you can see, the 10y and the negative 10y cancel, leaving me with 31x, since 25 plus 6 is 31x, and 55 plus 38 is 93x. I had these backwards right now. So now that you know what's left, now we need to divide both sides by 31. So we are going to divide both sides by 31. So you can see here that the 31s will cancel, and that means that x is equal to 3. Now that we have our x value, we're going to go back to one of our original equations. So either the top equation, 5x minus 2y equals 11, or the bottom equation, which is 3x plus 5y equals 19. Now I'm going to choose to go with the top equation. So I'm going to take our x equals 3 and plug it in right next to the 5. So I'm going to take this 3 and plug it in here. So it's going to look like this, the 5 times 3. 15 minus 2y equals 11. I'm going to take the 2y, and since it's negative on the left side, I'm going to move it to the right side, and it's going to turn positive. And I'm also going to take the 11, and since it's positive on the right side, I'm going to move it to the left side. It's going to look like this. I'll show you that one more time. The 11 moved to the left, becoming a negative, and the 2y with the negative moved to the right, becoming a positive. I moved my answer for this part up here to save room. And now I need to divide both sides by 2. Since the y is here and the 2 is next to it, I need to divide both sides by 2. My 2's cancel, not the y. The y does not cancel. I do not have a y on top of the fraction and a y on the bottom of the fraction. I only have a 2 and a 2. So those will cancel. And you can see that on the left side, the 3 and the 2 do not cancel since they're not the same number. And 2 cannot go into 3 evenly. Remember, the bottom number is the one that's dividing into the top number. And the 2 cannot go into 3 evenly. I'm going to have a remainder. So my answer for y is y equals 3 over 2. Just like here, 3 over 2. Now, I know the y ended up on the right side, but that's okay. It doesn't matter. 3 over 2 is equal to y, same as y equals 3 over 2. They're exactly the same thing. So now we need to graph, so we need to finish this problem and we need to graph it. Okay, for the first equation, Our y-intercept is going to be 11 divided by -2. So you can see that I wrote it here. -11 divided by 2. And 2 divides into 11 5 times, because 2 times 5 is 10. So that'll be 5 with the negative. And when 2 goes into 11 and you get 10, there's 1 left over since you have 11. So that's going to be 1/2 because of the denominator of 2. So we're going to go put a dot on the y-axis at -5 1/2. You can see here that it went off the graph slightly because you go down -1, -2, -3, -4, -5, and 1/2. Now let's go find the x-intercept for this, which I ended up getting 2.5, but y, let's go look. If you're looking for the x-intercept for the first equation, then you're going to take 11 divided by 5. 11 divided by 5 here. Okay, so 5 goes into 11 2 times, because 2 times 5 is 10, so that's the whole 2. But 2 times 5 is 10, and this is 11, so I'm going to have 1 left over. That'll be 1/5. I'm going to change that for you right now. Should be a 5, not a 2. So the denominator is 5 here, so that means the x-intercept is +2 1/5. Let's go graph that. If I go to the graph, I'm going to go on the x-axis, and I'm going to go to 2, 1, 2, and 1/5 would be as if I broke this little piece down into 5 pieces. Now, if the first piece would be very close to the line, so I'm going to put a dot here. Okay, you can see that I put a dot here, very close to the line. Now I can connect my 2 dots and form a line. On my second equation, the y-intercept is 19/5. So we're going to go see here, the y-intercept would be 19 divided by 5. So I put it here, 19 divided by 5. 5 goes into 19 3 times, because 5 times 3 is 15. That's the closest I'm going to get to 19. So that's the whole 3 here. Now, when I have 15 and 19, there is 4 left over. So that's the top of my fraction. That's where the 4 comes from. And over 5, because that's the denominator. Now, when I go to the graph on the y-axis, I'm going to go up 1, 2, 3, and 4/5. Now, if I were to divide this into 5 pieces, 4/5 would be very close to 4. That means my point is going to be right up here close to 4. And now for the x-intercept. Now for the x-intercept for the second equation, I got 19/3, which will turn into 6 1/3. So let's go look at that. For this second line, 19 divided by 3, because I'm looking for the x-axis, x-intercept. So 19 divided by 3, and 3 goes into 19 6 times. So that's this whole number, because 6 times 3 is 18. Now, since I have 19 and 18, there would be 1 left over, which is the 1 here. And the denominator is a 3, so over 3. So when I go to the graph, I'm going to start at 0, and I'm going to go along the x-axis, because this is the x-intercept. So I'm going to go 1, 2, 3, 4, 5, 6, and 1/3, very close to the edge of our screen here. So I'm going to put a dot there. There it is. And you notice that all our dots are either on the x-axis or on the y-axis. That's why they're called x-intercepts, y-intercepts. Now I need to connect these 2 points. You can see that the 2 lines, once they intersect, they are not quite intersecting at a lattice point. These points here on the corners of our grid are called lattice points, and I will write that word in just a second. But you can see that this is not exactly a lattice point. So our intersection is at 1, 2, 3 for the x, but it's not quite all the way up to 2. So we didn't get 2 either. We didn't get 2. So I'll make this into an improper fraction for you as well. Okay, you can see that I added the word lattice point, and those would be these points here. These corner points are called lattice points. Now you also can see here that I changed the 3 over 2 into a mixed number. So that means 2 goes into 3 ones with 1 remainder, so 1 divided by 2. So our point here is 1, 2, 3, comma 1.5. Well, we're not quite at the half, but you know, the grids are a little bit harder to get exact. It might just be because of my line here, where I didn't connect these 2 correctly. If I were to do a better job there, it'd probably be a lot closer to 1/2. You also have to remember that your point here was off the grid a bit. Okay, so when we write it as a point, it would look like this as an answer: 3, 1.5, or 3, and 3/2 is our answer. But we were pretty close there. Okay, on this page, I'm going to give you a hint for number 18. Okay, on number 18, you should multiply this whole entire equation by negative 0.95 in order to cancel your a's, and that's my hint for you. On number 19, I'm actually going to do that for you. So you can see here that the 4 would cancel. If I just had a 4 here, I would have a negative and a positive. So what I'm going to do is I'm going to multiply my entire equation on top by 4. So I'm going to get negative 4x plus 8y equals to 12. And 4x stays the same, minus 5y equals to negative 3. Canceling my 4's, I get 3y equals to 9. Dividing by 3, y equals 3. And now I can substitute the y back in. So it says here, which of the following are possible ways to eliminate a variable by multiplying first? So obviously multiplying the first equation by 4 definitely works. And then multiplying the first equation by 5 and the second equation by 2 would also work. So let's go take a look at that. If I had this one by 5 I would get 10, and this one by 2 I would get a negative 10, canceling my y's, so that would also work. And let's check the part C. Multiply the first equation by 4 and the second equation by 2. No, that would not work, because if I multiply this one by 4 and this one by 2, I would now get 8 and 4, and 8 and 4 would not cancel. Let's try D. Multiply the first equation by 5 and the second equation by 4. So multiplying the first equation by 5 would give me a negative 5, and multiplying the second one by 4 would give me a 16. If I look at my y's, multiplying the first equation by 5 gives me a 10, and multiplying the bottom equation by 4 gives me a negative 20. So neither one of my variables would cancel. On part E, multiply the first equation by 2. That would give me a negative 2. Multiply the second equation by 5. I would get a 20. That would not cancel. And for the y's, multiplying the first equation by 2 would give me a 4. Multiplying the second equation by 5 would give me a 25. That would not cause them to cancel. And part F, multiply the second equation only by 4. That would make this 16, would not cancel, and would make this a negative 20, would not cancel with the 2. So the only two that would work would be A and B. Now let's talk about number 20. The mistake made here was that they only multiplied the k on one side. You have to multiply both sides by k. So this should be a k here. That was the error. Now you can write a description of the error in writing. So description in writing, please. And I expect to see an answer there. I hope this helped you for this lesson.